Alrighty, so today we are going to go through our not necessarily the greatest test, just so that way we can get some more practice and we are ready to go for this retest tomorrow. A lot of the errors that I saw in general were silly algebraic mistakes, not remembering multiplication rules, not remembering what happens with exponents, wanting to change multiplication and division into subtraction. We only do that with our exponents, not whenever we need to. So, yes, we do have adding and subtracting in here, but that's when I have exponents and exponents. So we'll see those in a little bit. This first one, my derivative rule means I'm going to bring down my 7. I'm going to multiply with that 8. So 8 times 7 gives me 56. X to the 6, because it's 1 less than 7. The second one, a lot of people had issues with this one or didn't get it because for some reason they thought it was the cube root of x, when in actuality it's the square root of x. You can take a peek right there. Square root. It's just 3 times the square root. So first we have to rewrite that as 3x to the 1/2. Because we can't take the derivative of the square root. We have to change that into that exponent value. When we actually take the derivative now, I'm going to bring down that 1/2. So it's going to be 3 times 1/2. X to the negative 1/2. Because 1/2 minus 1 is the same thing as 1/2 minus 2 over 2. 1 minus 2 gives me negative 1. Oh, I forgot my other parenthesis, I'm sorry. And then when I multiply this 3 in, it's a fraction times a whole number. So that means that I multiply my 3 on top, because 3 times 1 is 3. My answer is going to have 2 in the bottom here. That 2 doesn't change. It's from my derived part here. But I know that this bad boy, my x, has that exponent of negative 1/2. And in order to make it positive, we're going to have to bring him downstairs. So that way he can hang out with the 2 that's down there. And it's just more correct to write your answers in this format. Some people on their test wrote 3/2 over x to the 1/2. Again, it's having fraction over fractions, and then you might think you can actually go ahead and flip and multiply, but that's not the case going on, because the x to the 1/2 is supposed to be hanging out with the 2, so I didn't necessarily mark off points. I just fixed it for you. That's why it's circled and then rewritten. Or some other people wrote 1.5 over x to the 1/2. We want to keep everything the same. We don't want to put decimals in with fractions. We either want it all decimals or fractions. So in this case, just get used to hanging out with fractions. Okay. This third one, I have to rewrite that x at the bottom. Ooh. Sorry, I just tacked my computer desk with my chair. So I have 8x to the negative 1. For some reason, when people wanted to do this one, they brought the x up with subtraction and had 8 minus x to the negative first. Which, the whole reason we're bringing it up is because it's technically multiplication. It's multiplication with a negative exponent. So it turns into division because of that negative. So because it's still division, it's going to, since it's still multiplication, they're going to stay multiplied together. When I go ahead to derive this thing, I get negative 1 times 8, which gives me negative 8, x to the negative seconds, which turns into negative 8 over x squared. This next one is x to the 1/5. That actually is the 5th power. Or excuse me, 5th root. My apologies. So bring it down. I get 1/5 x to the negative 4/5. 1 minus 5 gives negative 4. Again, just like the second problem, my x is going to come hang out downstairs with my 5. And then lastly, the derivative of any constant is just going to be nice little donuts. So that's the first 5. Let's take a look at the next 5. This first one on this part, or this next section, I notice I have an x. Whenever I take the derivative of x, it's going to end up just being the coefficient. So in this case, my answer here is just 15, because the derivative of that 4 constant is just 0. The second one, I have to bring down my 2, so 9 times 2 gives me 18. X to the second, 2 minus 1 gives me 1, so it's just 18x. Again, I have that x term, so it's just whatever's in front. This next one I have to rewrite, so I have 5x to the 1/2 plus 9x to the 4th. Before I keep going, if you've noticed, I haven't taken the derivative of pieces until I'm ready to take the derivative of the whole thing. The reason for that is if I take derivative of pieces and then try and do them later on, so say, for example, I went ahead and did this derivative part. Some people who tried to do that in pieces ended up then taking the derivative of a derivative again, which means that you've taken what's called the second derivative, because you've derived it twice, and that's not what we're looking for. You're making your life a little bit more difficult by trying to take it in pieces. You don't want to take the derivative until you're ready to take it of every single piece in your problem. So make sure you rewrite everything before you actually go to derive it. So I've rewritten this one, so I'm going to go ahead and do my derivative rules now. Negative 1/2. So I get 5 times 1/2 x to the negative 1/2 plus 36x cubed. This will give me 5 over 2 times x to the 1/2. That's not a 7, that's a negative 1. It's a little difficult to write on my computer right this second. It's charging, so I can't sit right next to it, so my writing's not the best, I'm sorry. And then I simplified this part because I had to fix it. There's nothing else to simplify with this second part. It's already ready to go, so I just bring it down again. And that's my answer. This next one, I have 3x plus sine. The derivative of 3x will just be 3. The derivative of sine, is cosine. Woohoo! Alright, next set. So we have to rewrite this first term. So I have 9x to the 1/3 minus cosine of x. Bring this down, I have 9 times 1/3 x to the negative 2/3. Derivative of cosine is negative sine, so this turns into plus sine. Because then I'll have negative, which turns positive. When I'm multiplying in this 9, I'm going to have 9 on top, so 9 divided by 3 gives me 3. X to the 2/3 plus sine. I hope this is starting to get a little bit repetitive. If so, that means you're starting to get it and you're ready to take your retest. If not, hopefully this is repetitive by the end of the video. I don't have to rewrite anything, so I can go ahead and start deriving. So 8 times 3 is 24. And then minus the 1 gives me the square term. And then the derivative of 5x is just 5. Derivative of 9 is 0. It's constant. Some people like to leave it as 9 and then add them together and make it 24 plus 14. Not sure how, because you didn't actually take the derivative and can't really add those two together because the derivative of a constant goes away. And this next piece, I need to pull apart anything that can be pulled apart. Now, if we look at my red example for a second, I got to move technically my 9 away and deal with it after I derived my x term. Well, the same thing is true for this term over here. The only difference, instead of 9, I have a fraction of 5 over 4. Oops, sorry, I already had the color. So this is actually 5 over 4 x to the negative third. That 4 is not going to change my answer here. All I'm going to do is, because it's a constant, I can multiply it later. It's not constant. I keep doing that. Let me back up a second. Because that 4 is a coefficient, when I go to actually take the derivative, all it's going to do is multiply in, just like when I did the 9. We saw this when we first did our limits, that it didn't matter what that number was out in front. It's just going to end up multiplying later. So I don't bring up my 4 because it's not going to change anything. I only bring up any variables that I can work with. So that's why I leave it as that fraction of 5 over 4 x to the negative third. So now that I've rewritten it, I can go ahead and take the derivative of it. So I'm going to have 5 times negative 3, which will give me negative 15 over 4 x to the negative fourth. Then negative 4 is going to come downstairs to hang out with the 4, so it's negative 15 over 4x to the fourth. All right, the difference between the last one and this one is I now have parentheses in it. Note the nice, lovely little parentheses here. I don't know if you can actually see that. There you go. Notice the nice little parentheses here. I cannot start bringing things up until that's simplified. So I have to simplify it. So when I do that, I still have the 6 on the top. 3 cubed, or 3 times 3 times 3 is 27. And then bringing that into the x is going to change it to x cubed. So now that I have it written to the exact start of the last problem, now I can pull out that x. So I have 6 over 27, x to the negative third. Go ahead and take the derivative now. So 6 times negative 3 is negative 18 over 27, x to the negative fourth. I get negative 18 over 27, x to the fourth. And then this actually can be simplified down. If you can simplify your constants, go ahead. Darn it. If you can simplify your coefficients, go ahead. Everything can be divided by 9. So when I do divide it by 9, I get negative 2 over 3x to the fourth. Again, are you gonna, did I count wrong if you left it in this form? No, I didn't. I just either wrote an equal sign or just didn't even do anything because most people didn't realize it could be reduced down. So I showed you it could. All right. I think we have this one and another one. No, okay, we've got 3 more after this. Sorry, I'm just trying to keep aware of where we are. In this next example, what do you notice about your exponent with your x? Yeah, it's negative. So that means that when he's negative on the bottom, it's like negative, negative, which turns positive. So when I bring him up, he actually turns positive again. Now, there's a couple different ways to approach this one. I can go ahead and start taking the derivatives and do multiplies and simplify. Or I can notice that, hey, 10 divided by 2 actually gives me an answer. It's 5. So then I can change my problem to this. Or I can start doing the derivative. It'll get you the same thing. So now when I derive, I get 10x. If you left it as that, I'm going to switch colors for a second. If you had left it as the original, when you take the derivative, you're going to have net 10 over 2 times 2x. 10 times 2 gives you 20. So then you have 20x over 2. 20 divided by 2 gives you 10. Hey, look, you end up with the same thing. What? Crazy. So yeah, sometimes there's a couple ways to add in a couple different, it depends on if you have how many coefficients you end up with. This next one, parentheses again. So I can't do anything until I get rid of the parentheses. And I can't distribute a negative exponent. I can only distribute exponents that are positive. So in order to make it positive, since he's downstairs, he's got to come up. So I have 5 times 2x quantity squared. Again, I can't do anything till I simplify this, so let's go ahead and simplify it. So I have 5 times 2 squared, which ends up being 4. I'm just going to go ahead and change that to 4x squared. Again, that 5 out front is just a coefficient, so I can either multiply it in or I can leave it. If I leave my 5 out front for a minute and take the derivative of what's inside, that'll give me 8x, and then I multiply through and I get 40x is my answer. Or if I wanted to at this step, I could multiply it in to give me 20x squared. Derivative of this gives me 40x. Either way, as long as you're only dealing with a coefficient out front, you can wait. You can either simplify right away or you can simplify later. Either is not going to matter. What matters is, bear with me for a second, this last group here in the bottom, so this is the last row on your quiz. Notice how this isn't just a coefficient. It becomes an actual variable. When you deal with variables, you can't derive and then multiply through. It's just like with our fractions. We have to simplify everything first. All right, next one. I don't have to change anything, so let's just go ahead and start deriving. So 8 times 3 is 24. Derivative of 7x is 7. Bring this down, I get plus 10x to the negative third. When a lot of people got to this step, they gave everything a denominator. But I ask you, does everything get a denominator? Do I have negative exponents on all problems on this example? Sorry, I just spit on my computer. I was trying to write it off. I don't have extra negatives anywhere on here. So the only thing that gets that denominator then will be whatever has the negative exponent. So in this case, the only term that has that fraction is that last one. We'll see that when we do a couple more examples here in the beginning. In a few moments, sorry. All right, this next problem. Do I have to rewrite anything? Nope. So let's go ahead and take the derivative. 5 times 4 gives me 20. So I have 20x cubed minus 12x to the negative fifth plus 3. So I have 20x cubed minus 12 over x to the fifth plus 3. All right. Next set. I want to try something here. See if it stays there, if I have to change it every color. I have to rewrite this first problem because I have x's in the denominator. We don't like uxe in the denominator, so we're going to fix it. So I have 5x squared minus 9x to the negative third. I hope this looks better. I realize it's been kind of hard to see, so I switched the thickness of my writing. So now I can go ahead and take the derivative. I get 10x plus 27x to the negative fourth, which gives me 10x plus 27 over x to the fourth. Same idea, this next one I have to rewrite, so I have 7x to the fourth minus 8x to the negative fifth. 7 times 4 gives me 28, so 28x cubed. 8 times, negative 8 times negative 5 gives me positive 40. Negative 5 minus 1 more gives me negative 6. So my answer is 28x cubed plus 40 over x to the sixth. So for these next two, I can't just take the derivative of the top and the derivative of the bottom and just leave them. I have to simplify what's going on first. So we talked in our notes about how when I add fractions together, I can put them together as long as the bottom's the same. So it means that I was able to create this whole top because every single bottom was exactly the same number. So it means I can pull everything apart and give everything that denominator. The reason being is that everything is technically being divided right now. So I'm not going to do this much work in the next example. I'm just backtracking and talking about what we've already spoken about. So in this first term, if I have 4 x's on top and 2 on the bottom, it means I'm dividing them out. So I can start canceling. It's the same thing as saying 4 minus 2, which will end up giving me 2. So my first term, when I rewrite it, all I've done is simplified here. Gives me 2x squared. This second term, I've got 2 x's on top, 2 x's on bottom. They all cancel out. I'm only left with that negative 4. I have no more x's to hang out with me. And then my last one. I don't have any x's on top, so it means they're all hanging out on bottom. When they're all hanging out on bottom, it's just there with that negative. So now that I've gotten to this point, I can derive it and take the derivative. So 2 times 2 gives me 4. So I get 4x. The derivative of a constant is 0, so he's no longer there. And then I get plus 14x. So negative third, because negative 7 times negative 2 is positive 14. So I get 4x plus 14 over x cubed. Now we did this together. And then this last one. So essentially, between my red one and what I'm going to do now is I ended up subtracting these all by whatever is on the bottom. So I'm going to subtract, oh, you can't see that, I'm sorry. So I've got like double screen going on right now. So what we did in these last ones is I essentially subtracted this exponent with this exponent for each piece. So I'm going to do the same thing I did. Same thing on this one, so I'm not going to write this step. If you need to do this step, that's fine. Go ahead and pause the video and get to the step, and then come back when I am down, ready to be at this step right here. Okay, so 4 minus 3 gives me 1, so I'm left with 6x minus 5. 2 minus 3 gives me negative 1, so I have negative 5x to the negative first. Minus 3, I've got 1 minus 3, which gives me negative, oops, forgot my x on that one. Which gives me x to the negative second, because you're right, 1 minus 3 gives me negative 2. Now I can go ahead and take the derivative of everything. So the derivative of 6x will be 6. So I have 6 plus 5x to the negative second plus 6x to the negative third. Let's fix our answer to be more proper. I get 6 plus 5 over x squared plus 6 over x cubed. Again, I can't put any of those together because none of them have the same denominator, and I have 2 different denominators to begin with, so I can't even give everything 1. I don't get to magically put it together. All right, last line. Correct. Okay. When we kind of already spoke about these two, I need to go ahead and multiply everything through first. I can only leave it outside if it was just a coefficient, because coefficients I can pull apart and multiply later. So I get 5x cubed minus 3x squared. So let's take the derivative. Gives me 15x squared minus 6x. I get 6x to the fourth minus 42x. 6 times 4 gives me 24x cubed. And then the derivative of 42x is just 42. These next ones are essentially radicals that were already changed for you. So, hey, at least you don't have to do that rewriting step. You're welcome. When I do this next one, I'm going to go ahead and just start bringing everything down. So I have 3 times 3/5 x to the negative 2/5 minus 2 times 2/3 x to the negative 1/3. Three times 3 gives me 9, so I have 9 over 5x to 2/5, excuse me, I apologize, I looked at the wrong part. Minus 4 over 3x to the 1/3. I can't simplify any of those fractions, so I'm just going to leave them as funny numbers, just because I can't do anything with it. Alright, the very last one, I have 6 times 3 over 4 x to the negative 1/4 minus 2 times 2/5 x to the negative 3 over 5. Oh, go away. Sorry, computer decided I need to open. Being too close to my screen. There we go. I'm getting too close to the edge of my screen, so it keeps opening my action center, my notification center of my emails and all that fun stuff. Which, yes, I know you can't see. Mwahahaha. I only have it, so the only thing that records is actually my smartboard. And nothing else. So, when I go ahead, I already derived it, so let's simplify it. 6 times 3 gives me 18. So I have 18 over 4x to the 1/4 minus 2 over 5. Oops, not 2. 2 times 2 is 4. I was simplifying something else in my head. Sorry about that. 4 over 5x to the 3/5. My simplification was I can reduce both of those by 2. I can divide 2 out of both of those. So I get 9 over 2x to the 1/4. Hence where that 2 came from. That's actually what I was thinking of. I cannot reduce these, so it's going to say negative 4 over 5x to the 3/5. Alright, now that we have gone through this, I hope your retest goes a lot better tomorrow.